Hi dear friends, after learning about OWASP's top 10 security vulnerabilities, about Android APK sandboxing and signing, let's talk about authentication and encryption. Authenticated encryption with associated data are forms of encryption which simultaneously assures the confidentiality and authenticity of data. These attributes are provided under a single easy-to-use programming interface. The main difference between authentication and encryption is that encryption transforms meaningful data into what looks like gibberish using a secret that can also be used to reverse the process. Authentication is a process of convincing a gatekeeper that you are who you say, typically by proving that you know a secret. Now, before I start to tell you about authentication and encryption in details, you should be aware of some key terms like gatekeeper, auth token, key store, key master. Gatekeeper. The gatekeeper subsystem performs device, PIN, pattern, password authentication in a trusted execution environment (TEE) that enrolls and verifies passwords via an HMAC key. Auth token. The industry standard way to deal with authentication to third-party services is the OAuth2 protocol. This protocol provides a single value called an auth token that represents both the user's identity and application's authorization to act on user's behalf. Key store. The Android key store system lets you share or store some cryptographic keys in a container to make it more difficult to extract from the device. Once in key store, they can be used for cryptographic operations with the key material remaining non-exportable. Key master. It is a trusted application is a software running in a secured context that provides all of the secure key store operations, has access to the raw key material, validates all of the access control conditions on keys, etc. Android supports the concept of user authentication generated cryptographic keys consisting of cryptographic key storage and user authenticators. Cryptographic key storage. Android stores cryptographic keys using features such as hardware-backed key store and key master. User authenticators. Android uses Gatekeeper for password or PIN or pattern authentication and fingerprint for fingerprint authentication. Biometrics. Android version 9 and higher supports Biometric Prompt API that allows developers to integrate biometric authentication into their applications in a device. Biometric-based unlock security are mostly measured on the basis of false accept rate or FAR. Now through this diagram you can see the steps being followed from 1 to 4. Then the authentication is provided using PIN or pattern or password, or when it is provided using fingerprint. Now we come to the encryption part. Encryption is a process of encoding all user data on an Android device using symmetric encryption keys. The encryptions maintained in Android device are of the following types: file-based encryption, metadata encryption, and enabling Adiantum. Now what is file-based encryption? In this type of encryption, different types of files can be encrypted with different keys and unlocked independently. Android 7.0 and higher versions support this type of encryption. It also supports direct boot, which allows a device to direct boot to the lock screen. Metadata encryption. When file-based encryption is used, information such as file data, design layout, permissions are not encrypted. These information are called file system metadata. It was introduced in Android 9.0. Metadata encryption encrypts file-based encryption information as well as metadata information. In metadata encryption, a single key is present at boot time, which encrypts metadata information. The key is protected by key master, which is again verified by boot time. Now the third type of encryption, which is enabling Adiantum. Adiantum is an encryption mechanism in Android operating system that is used on those Android devices whose CPU lacks AES instructions. Due to lack of AES instructions, providing Adiantum encryption on those devices provides lesser overhead. Thanks everyone for watching the video. Stay tuned. I'll be back with some more videos and giving you information, some more security mechanisms that are followed in Android.